170, then 21, then 149, then 57. This is the IP address, and this is the subnet mask 255.255.192.0. How we can find subnet ID easier? Look at here. When we are using 255 in one octet of the subnet in a subnet mask, this means that the equivalent or for example, the bits in the network, equivalent bits in the IP address are the for example network part. Because of that, network or subnet ID, because of that we can say that 170 is one part of the subnet ID. You know that here I'm going to find the subnet ID, and then also 21. I'm sure that 170.21 are part some part of the subnet ID. And also here we have a question. Let me talk about that. But here, as you can see, we have 0 in subnet mask means the equivalent bits are the host bits. Because of that, we can say that this part of the IP address, okay, this part of the IP address is not part of the for example the subnet ID. Because of that, let me to use here 0. Okay, this means that for the octets that we have 255 in the subnet mask, we can say that these octets are residing in the for example residing the subnet ID. And for the octets that we can see the 0 in the subnet mask, we can say that the equivalent bits in the IP address are not part of the subnet ID, and we need to use 0. Here now we have one octet, that this octet we can see 0 or 255. We need to find the subnet ID for subnet ID bits for this octet 3. It's so easy. You need only to convert this octet, not other octet. Look at here. This is the octet 3. As you know, I converted before 149, and this is the 192. That's it. Okay, and after that you can easily see that we have only 2 bits of the networks in this octet. Because of that, as a result, we can say 170.20, then for example, as you know, 128, because we have only 2 bits of networks, 128, and then 0/18 is the subnet ID. It's easiest. It's a little easier, because in this method we don't need to convert the octet 1, octet 2, and also octet 4. We only converted the octet 3 to binary in IP address and also in subnet mask. Because of that, if you want to find the subnet ID, the easiest method is that writing the octets that you can see the 255 in the subnet ID for them without any change, and also you can change the subnets that you have in the equivalent part of the subnet mask 0 to 0. Okay, and after that only you need to find the subnet ID or network bits in the for example octet 3 that we don't have 0 or 255. It's so easy. For octets that we have 255, please write again the IP address. For octets that in subnet mask that you have 0, please change the IP address to 0, and only you need to find the network bits in the octets that we don't have 0 or 255 in the subnet mask. That is so easy. Okay, it's easiest and faster than the first method. But how we can find the broadcast ID? Here again we have the same story. Let me to write here. In this time I'm going to find the broadcast ID or broadcast address. Okay, it is similar to finding the network ID or for example or subnet ID. Let me write here again. In the subnet mask, when you have 255, you need to write again the IP address similar to the subnet ID finding. But in the field that you have 0 in the subnet mask, you need to change the equivalent bit into the IP address to 255. That's it. And after that, In the third octet, you know that here we have 192 and this is the 149. These first 2 bits are bits of the network, and these 5 bits are bits of the, for example, host. We need to change all of the bits of the host to 1. That's it. Okay, let me to calculate it. 172. Okay, 170. This is 170. Okay, then here again we have 170. Then dot 20. After that 191.255. As you can see, this is equal to the broadcast ID that we find before. Look at here. Here we have the same subnet ID, and also this is 21. Yes, this is 21. Okay, and also this is 21. Here we don't have any change. After that, as you can see, the octet, the third octet is 128 in subnet ID and 191 in the broadcast ID. Both of them are same. It's so easy. Let me to review how we can find subnet ID faster. First, you should write the IP address, then you should write the subnet mask. In the octets that in subnet mask you have you can see 255. You need only write the IP address without any change. In the subnets that in subnet mask that you have 0, you need change the equivalent bits in the part of the subnet mask you can see 0. You need only write this, change the subnet the IP address to 0 and write it. And after that, in the subnets that in the octets that you don't have 0 or 255, you need to find the network bits. Then you should change the host bits to 0. Finally, you will have the subnet ID. In broadcast ID finding, again, about the octets in subnet mask that you have 1 or 255, okay, you need to write again the IP address. In the subnets that you have, in the octets that you have 0 in subnet mask, you need to change the IP address to 255, and after that, in the octets that you don't have 0 or 255 in the subnet mask, you need to find first network bits, and after that, about the host bits, you need to change the bits to 1, and finally you will have the for example, broadcast ID. This is the second method for finding the subnet ID and broadcast ID. After that, again, you can use the addresses between the subnet ID and broadcast ID for the for example, calculation for the using for the IP address assignment, for example. This is the second method. But we have another method. Let me to talk about the third method. In third method, we are using the classful view. Let me to write here. Look at here. You know that I talked before about the classful view and also classless view, okay, of IP address. Classful view. Let me to write here. You know that the IP address of in this scenario is 170. Okay, 170.21, 149.57. This is the IP address that we have, and you know that in classful view, because 170 is one IP address residing in class B. You know that in class B we have 16 bits of networks. Because of that, and you know that here we are using /18. Okay, this is /18, as you can see here. This is /18. Because of that, the first 16 bits are network bits, you know it. After that, we have 2 bits of the subnets. After that, we have 5 bits of the host in this octet. Again, 8 bits of the host in the, for example, last octet. This is the classful view, you know it, okay? Let me change the subnet bits. The first network is 170.21. Here we have SS or and subnet bits. Okay, these are subnet bits. We can use 00 for the first subnet. After that, we can use another. We can create another subnet. Let me write here. 170, then 2101. After that, let me write all of them. We have 4 type for for condition 170 21 again 10, and after that finally look at here 170, okay, then dot 21 dot 11. Okay, you know that with 2-bit we can create four for example conditions. Okay, now we need to find the subnet IDs, the subnet ID of this IP address. Okay, you know that for subnet ID we need to use in all of the bits of the host 0. Okay, let me to write here 60. This is the 60 dot again 80. Look at here 80. That's it. So easy. Let me to copy these bits for the second subnet. This is for second subnet, this is for the third subnet, and this is the fourth subnet. Okay, now 170.21, okay, dot for example 149.50. this is our IP address, and we write 170.21. then here I use the four conditions. Okay, let me to convert these conditions to the decimal. In the first network we have 170.21.0.0, okay, /18. In the second network we have 117.21.64, this is 64.0./18. After that 170.21.128.0/18, and after that 100, look at here 117 for example 100.21.192.0/18. you know that here we have four networks, and this IP address, okay, 149, residing in this subnet, okay, because this is between 128 and 192. Because of that you can easily find the subnet ID of this network. Look at here, let me to compare the subnet ID with this value. Subnet ID is 170.21.128.0/18, and this is exactly the same value we calculated before or here in here. Okay, because of that, if you want to find the subnet ID easily, you can easily find the subnet ID with class full view. First you need to find the class